Okay, I thought we'd take a quick look at this RCA RF signal generator that my wife's nephew picked up for me. It's a model WR-49A. It's pretty dirty, but overall, I mean, it's a metal case and it doesn't look like it's in terrible condition. I was thinking I might just go ahead and try plugging it into my MFP and just see if it powers on. If it's got something shorted, hopefully it'll just trip the breaker and not work, but I think I'm going to give it a shot. Let's turn some power on here and turn everything down so we bring it up slow. I just got everything running on the MFP. So let's just, I'm going to zoom back a little bit so you guys can see a little bit more. So I'm going to go ahead and turn it on. So let's go ahead and give it some voltage. Wire so I can see my voltmeter. Okay, we're about 36 volts right at the moment. On about 20 milliamps. About 50 volts. 55 volts, 57 volts. Not tripping the meter. I don't see anything with my indicator light down there. 66 volts. Don't see anything with my light down there. About 83 volts. Haven't tripped anything. I do see that light on now. Light is on. Get some more volts. About 90 milliamps, 106 volts. Take it on up. 100 milliamps. There's 115, we'll take it up to 118. There's 118 volts. Okay. So you got 118 volts, pull about 120 milliamps. Successful power up. Doesn't look like anything's getting torn up at this point, so let me get the scope hook up to it and see if it's doing anything. Alright, well here it is on the scope, and it is putting out. Right now I've got the signal generator set on about 150 on the scale. If we look at the signal generator, it's 150.53 kilohertz. So if I lock my display, it's on 149.7 kilohertz. But again, like I said, it's you know, varying here. It's varying between 148 to 152. There's one right there where I locked it right on 150. And just moving on up some more. Let's take it on up to the top of it. That's 200 right there. So it's actually, you know, kind of putting out, considering it hasn't had anything done to it yet. 202. Okay, so let's take it up to the B scale. Which B scale is, A scale is 85 to 200, B scale is 200 to 550. So I'm going to take it to B scale. We should be close to 550 right there. And we're 526, 527. So that's a 527. Kind of ragged, but there's 540. Stopped on 540. This should be 550. Alright, let's take it on down to 200. Let's take it all the way down to 200. That's the bottom of the scale. Let's see what we get. 220, 220. Pretty dirty signal, but it is actually working. So that scale is actually working. Okay, so let's take it to C scale, which is 550 to 1600. See if C scale works. So right now, if we're on C scale, we're about 700, and 695. $16.95 is pretty good for 700, so let's take it on up to say 1200. It's 1204, 1204. So the C scale appears to be working. Let's take it on up to the top of the range, which is going to be 1600, which should be about right there. And we're at 16, there's 1587, 1612. So that's, you know, it's erratic. There's 1612 right there. Alright, let's take it up to the D range, which is going to be megacycles and runs from 4.8 to 1.6. So let's put it on 4, take it up to D. And that's 4 megahertz. Megacycles, that's exactly what I got. It's sitting on, it's 4. That's 394. To stop it, around 4.040 megahertz, and I'm on 4 on the scale, so that's pretty good. Okay, so let's take it on down. Let's take it down to 2. There's 2, and it's right on to 1.980, 1.99. And so let's see, so that scale's working okay. Take it down to the 1.5, which is the end of the scale. 1.5, 1.50. They're definitely not clean signals, but they're there and they're functioning. I'm impressed so far. Okay, now we're going to take it to the E scale, which is 4.7 megacycles megahertz to 14. So right now we're on E. Let's take it to 4.5. Let's see what we get on this. 4.395, 4.2, 4.25, 4.25, 4.25. Okay. Let's take it on up. Take it on up to, let's take it up to 13. There's 13. We're at 12.9, 12.5. Alright. So all of these scales and all of these ranges appear to be working. We're going to take it to F, which runs from 13 megahertz to 30, goes to 31 on the scale, but we're going to take it to 30 and see what we get. We got, that one's all over the place. We got 28, we got 14, we got 5. As you can see, it's all over the place. There's 26. There's 30. So yeah, it's all over the place. But I'm impressed because all of the ranges are working. I'm on 16 right now, and that's 16, 15, 17. It's jumping around, obviously. But all the ranges are working. So I'm happy. This didn't cost me anything, and I think I can make it a little better and a little more accurate. So let's get this thing apart and see what it looks like inside. Okay, I might add that it's got this crappy little coax cable on it, which is more like a RCA jack type thing. I mean, so I put their cap on here. It's probably a 0.1 cap on there. I'll probably want to change this over to B and C, or at least get a better situation on this. Maybe not. Maybe I'll just keep it the way it is to keep it original, assuming that that's an original cable. I don't know if it is or not. But let's get this thing apart. I'm going to get a screwdriver. Alright, it's got a bunch of these little screws all over the place. Let's just go ahead and whip them out. I don't know what needs to come out, what doesn't need to come out. We're just going to take them all out and figure out from there what we need to do. 12AU7 and a 6C4 in there. Some ceramic caps. You guys, where you can see that a little bit. I'll zoom in a little bit. 6C4 here, 12AU7 there. Ceramic caps. See the tuning condenser in there. See some adjustment plugs in there. My trusty dusty little screwdriver here. Get these off. I'm not sure what year this is as far as how old the caps are, because I don't have the schematic for it yet or any information like that. Yeah, just use screws in these as well. Okay. But thus far, I'm impressed. All right. See what we got here. Just got them off. See the light. You know, we still got the light in there. Oh, it's just a cover. Okay, so good. So the light is not part of this. You can see that. That's just a lens. It's just a lens. I think that's going to clean up really nice. Now, I think this whole thing should slide out the cabinet like that. Like I said, I think that cabinet's going to clean up really nice. I mean, it's got a little damage right there, but definitely not worth worrying about repainting or nothing. I think it's going to clean up really nice. Alright, let's take a little bit better look at this. So that's our knob for turning the frequency. So it's friction drive off of this, which is, that's all that actually is. So look at that. It's just a friction drive. So that's the friction drive. You see from the back side, right there. That's all it is, friction drive. Let's turn it up. Alright. Thing's really clean inside. It's got some big bumblebee caps in it. It's got a couple of resistors that I'll check, but I'm sure they probably will be fine. I see it's got a selenium rectifier in it. And it's got this 40s, 240s microfarad filter capacitor in there. Yeah, I think this would be a quick down and dirty restoration. I'll have to get me a conversion chart for those caps to see what they're supposed to check out at and see how far off they are. But we know everything works. So really, I'm going to be spraying these pots out a little bit, although they seem to be working pretty darn good, and check my resistors and get an idea where we're at. In fact, get this thing where you guys can see it better, and we'll check some of that stuff. Okay, so I'm going to check a couple resistors here. I think I got it set up where you guys can see my meter back there. So I've got a triple orange here resistor, which I believe is 33, 32, 33K, and we got 32.8, so that's right on the money. I think it's supposed to be 33. So let's go with 5 bands. We got gray, red, black, red, 202 ohms per my calculator that I've got here. Gray, red, black, red. No, I went too many placeholders. Actually, let me try that again. Gray, red. I've got an app on my phone, by the way, guys, so you can see what I'm doing here. I'm just punching it in. So it makes it easy for me. I can't memorize this crap at my age. So 82K is what it says it's supposed to be. Let's see what it comes out with if I'm reading that correctly. We'll see what we got. Maybe if I can get on it. 82K is what I calculate. And we got 8.7K. So that wouldn't be right. But then I'm not sure I'm right. Alright, so I'm not going to worry too much about that till I can look into it a little bit better. And I got another orange up here, if I can get onto it. And it's 32.933, so that's 33K, that's what it was supposed to be. And then I got a blue, gray, brown in there. Let's see what the blue, gray, brown is supposed to be. Blue, gray, brown, 680 ohms. So let's see if we 755.5, so it's within 20%. That's the one that's been the furthest out so far, and I don't really see any others right there visible. But overall, I don't see a whole lot wrong with this thing. Let me see if I can put some voltage to this cap and see how it tests out. It didn't really have much hum to it, so I'm not too concerned about it. Let me see if I can get something hooked up to that thing. Alright, I'm going to check this cap just for the sake of checking the cap and see what it comes up with. It's supposed to be 240s, so this is one side of it, and we're coming up with 121 UF, so that's like way high. Alright, let's try the other side. And that's coming up as 124 UF, 122. So they're supposed to be 40s, and they're both coming up as 120. And I want to test it another way as well. So let me see if I can get, if my comparator is still working. The cat's knocked it off the shelf a few months ago, and my comparator may not be working, but we're going to give it a shot. Okay, so I got my ICO 950A connected up. Now, this used to be one of my favorite tools, but my cat's knocked it off the shelf about a year ago, and I haven't gotten back into it to check it all out. But I don't trust it at this point that well. But we're going to take a look at it anyway. Now, I know that the eye-tube has rotated. It used to have the eye-tube with the indication down, and it's more like a 5 o'clock at this particular time. But let me zoom you in, and I'll show you what we've got right at the moment. Hopefully you guys can see this eye-tube. Okay, so right now, if I turn this until my eye-tube closes, it closes about right there, which on this is about 340 microfarad. Now, on the meter it said it was like 122, I think. So I mean, this thing could be off, but it's definitely much higher than, you know, the 40 that it's supposed to be. Opens up. I don't know if you guys are seeing that or not. Let's see if I can crank this up a little bit more to get an angle so you guys can see, maybe. Okay, so I killed a few lights to get you a little bit better view of it. So you can see it opens up as I come around. When I get it to close completely, I'm on about, actually when I close this completely, it's about 450 on the actual scale here. If I mess with my power factor, it even makes it worse. Right there is about 500. So like I said, I'm not sure how well this can work. What I want to do is try and put some voltage to it. Now, these are supposed to be 150 volt working voltage. So let me get this thing on the test the voltage. So here is 10 volts, and it should snap back open. Here is 10 volts right there, and it's not snapping open. It should open back up. It should close when I hit the voltage and open right back up. So whether I go to anything higher than 10 volts, that's 10 volts. 10 volts it closes, it does not open back up. So I guess bottom line is I think I'm going to change the electrolytic on it, even though it didn't have much hum, and the unit's working. I'm just going to get that old crappy electrolytic out of there, and we'll change those out. So I went online and I found a program that showed you how to identify the bumblebee capacitors. So on my little dry erase board here, I wrote the numbers that correspond to the colors and the way you figure it out. And I sat there and I figured out all of my bumblebee caps and put their orientation in here, and I put their values in here. As you can see, I put green check marks next to the ones that I had in stock, and the red ones I didn't have in stock, so I just ordered them from DigiKey. Then I also went online and did some research, and I actually found the electrical schematic for it. So I printed that out, and then I laminated it, and let me show it to you. So this is page 1 of 2, because I couldn't get it all on one lamination, so I did 2 separate laminations. This is front and back. But what I did was I highlighted all of the capacitors and resistors, and because I had to look at them through the magnifier, I went ahead and wrote them down and their values up here. And then I compared the values that I had here versus what I had determined on that board that I just showed you, and they were exactly all right. So obviously I must have did it correctly. But that's the first page, and then that's the second half page. Same thing up here. And then I also have a block diagram that I found for it as well. So we should be in pretty good shape. Once I get my parts in, we'll get these caps changed out and get the resistors all checked out and see what we got.